Okay, for the next step, what we were going to be wanting to do is we're going to want to start playing with one of the faces of each one of the layers. So let's start with just one layer. And this is something, so we have the rotation that's going to be affecting the whole layer, so we can leave this to the bottom. The easiest way for us to do that is to actually have each one of these faces to be kind of as if it was a single object with associated to a single point. And we can do that with an assemble. And what the assemble is going to do, if we turn on the create back geometry, what you'll see is that when it comes in, the geometry is pretty much based on 180 points. After the assemble, what we have is 32 points and 32 fragments. Each one of these fragments has its own centroid, and the centroid will correspond to each one of these points. We can have a look at the points here, and we should be able to see the points. Let me make sure. Let's go through the whole thing. There they are. Okay, so these are the centroids that we're going to be playing with, and the centroids will take with them the actual geometry. This will just make it easier for us to control. Instead of having to worry with which one of the points of each one of the faces, we just have to worry with one point that represents the whole face. So finally, the next thing we'll want to do is we'll want to create a nested for each loop that would go through each primitive. Okay, so going through each layer, on each layer we're going to be packing all the pieces, and inside through each layer we're going to be going through each one of the primitives until we cover all of them. So this will allow us to make some changes to the actual geometry per primitive per layer. So let's create also a meta import node. And the next thing is going to be pretty much just playing with the scale. Let's start with affecting all layers the same way, all faces the same way, sorry. Okay, doesn't look like much. And the reason for that is because we are using this pivot. The pivot for the scale is going to be the origin. So let's change that and make sure we're actually using the centroid of whatever's coming in. Okay, so X coordinate of the centroid, Control A, Control C, Control V, switch to an I, Y, and then Control V and switch to a Z. Okay, so now if we play with the scale, you'll see that we are affecting just, and we can play with this while it's actually rotating. Go through the whole thing. Okay, and we'll be able to animate each face as it rotates. We don't really need to see the points anymore. Okay. Now, the idea is for us to actually be able to have this be animated and kind of creating an interesting motion automatically without having to think too much about it. So the way we're going to be doing that is, instead of using a uniform value, we will have we'll use a specific value from that we're going to be reading from each one of these points. Okay, so from each one of these points we're going to be reading one value that will be assigning before entering this loop. Okay, we're not going to be assigning the value right before we read it. We're going to be assigning the value here after the assemble, and once we have that value assigned, when each one of the points goes into the next loop, we'll be able to read a specific value for each one of the points, and each one of the faces will be scaled with its own particular value. And the easiest way for us to do that will be to just make use of the attribute noise. Attribute noise, and let's call this, it's going to be a float, and let's call this my scale. let's try to visualize this. I think the easiest way will be to create an add temporarily, just delete all the geometry so we can have a look at the points. And let's make this visible. We should also be able to adjust, right click, go to my scale, and let's say min max 0, 1 sounds good. I like white to red. So white's going to be red, and 0 is going to be white, and 1 is going to be red. Now we are interested in having the noise animated. We don't need a fractal. This is going to be pretty standard values, and the element size needs to be smaller, otherwise we don't see much difference. I'm going to try and make this a bit more obvious. Maybe we can increase the point size to 10. Again, as you can see, they are changing. The value is changing throughout the time. Okay, we can make the change be faster. Here on the pulse duration, we can make it 0.5, but it is changing. Now the range of these values, because of this amplitude, it's going to be from 0 to 1. We can check it here, my scale. So the minimum value at this point is 0.2, approximately, and 0.7. Okay. You can always remap the values. You can either use a remap ramp here, right from the attribute noise, enable remap ramp. You can set the proportions if you want to have more or less, but in this case, I'm gonna leave it. And post process minimum and maximum, also not what I'm going for. So I'm actually gonna do a remap after this. For now, attribute remap. Say it's my scale. The new name is non-existent, and the input minimum is going to be 0, 1. But I want them to not go over 1, but I also don't want them to go this low. So maybe 0.5 will be enough. Okay, so now we should have values. It's not going to be as visible because we don't have as much contrast, but as you can see, the range is now adjusted differently. Let's just remove this. And how are we going to be reading this value? So the value we're going to be reading using, again, an expression for reading the points. So here on the transform, we're going to be using the point expression. So it's slightly different than the point expression that you usually would use in Vex. On this one, you have the input, or whatever you want to, where do you want to read the point from. Then the next one is going to be the point number, the attribute, and the index of that attribute. In case it's a vector, you might want to have several ones. In this case, it's a float, so it's going to be 0. It's going to be my scale, and this is going to be 0 because we only have one point entering at a time, and that's all we want to read. So it's always going to be 0. So input 0. Next, we have the point number, which is going to be 0. The attribute is going to be my scale, and finally the index is also going to be 0. So now each point will have its own different value, hopefully. Let's see. Oh, let's turn this one off, and it should be okay. And this is what we get. So now we have the animated scale of these elements. You can play with the speed at which they're animated, with the variation of the range. So if you want to have something a bit more extreme, you would go with the minimum scale of 0.2 maybe, and you have something more like this. You can also, if you want the motion to be faster, you would just go here into the pulse duration, put it 0.2, so it would be more frenetic. Or if you want it to go a bit much smoother, then you can just go with 2. Depends on how fast you're going, I guess. So here on this transform, we have this rotation multiplier. Let's go with 20. It's a bit more dynamic, I guess. And here on the attribute, on the noise, I think I might go with a pulse duration of 1. The cool thing about this, of course, is that you do have the ability to affect different layers based on just playing with this value. But if you want things to actually act a bit more chaotic, or notice a bit more difference between one layer and the other, you should always kind of integrate the iteration of this first one into whatever randomness you're trying to apply. So here on the attribute noise, it would make sense if we would, for instance, here on the offset, we could, let's work on 3 axes. Stop this. So let's make sure that at least on one of the axes, we actually have that being affected by the iteration number. So we can again create a spare input, add spare input, drag this one here, and this noise is going to have an offset from layer to layer. If we use the expression, the usual expression, so it's -1, iteration 0. Okay, so let's multiply this by something. Let's multiply this by 100. And that way we have a bit more variation between layers. Let's add a few more. And things start to get a bit more interesting, I guess. Okay, so this is what we have so far. And we pretty much set up the basic structure that will allow us to do a lot of different things. So the goal was for us to have or the main thing is for us to have a way of going through each one of the layers, and on each layer going through each one of the pieces of each layer, and being able to affect it in an organic fashion, but also in a very chaotic, even though controlled way. So on the next one, we'll be kind of going through other things that we can do and how else we can add control to this, so some of these transitions can actually be animated. So see you on the next one.